So, have you ever looked at just a massive wall of numbers and wondered, okay, how do I find the one single value that actually captures the heart of all this? Well, finding the true center of your data, it's not just some boring math requirement. It's actually a super crucial real-life skill. We use it for everything from predicting sports scores to, figuring out a monthly budget. I am so pumped to guide you through this explainer today. Think of me as your personal tutor. We're going to break this down step by step on our digital notebook. So grab a pencil and let's get ready to master the arithmetic mean.
Okay, let's dive into this. Right here on our mind map, you can see exactly where we're heading today. We're exploring the absolute core of statistics, focusing right in on Lesson 2. We've got our calculators ready, the digital graph paper is laid out, and we are zooming straight into the arithmetic mean.
Here is our roadmap for this explainer. First, finding the center. Next, calculating the basic mean. Then, tackling frequency tables. After that, spotting misleading data. We'll follow that up with some guided practice, and finally, your turn with a challenge.
All right, Section 1, Finding the Center.
In statistics, dealing with raw data can feel, pretty overwhelming. We really need a reliable way to summarize a whole group of completely different numbers with just one single representative value. And these summarizing values, they're called measures of central tendency. Sounds fancy, but they just describe the center of a data set. The big three you absolutely need to know are the arithmetic mean, the median, and the mode. Think of them as just different tools in our mathematical toolbox, all used to find the middle of our data.
Let's look at a really quick example to see how they differ. Imagine we have the ages of 5 sports players, right? 15, 15, 16, 21, and 23. So, if we want the most frequent age, the mode is 15. If we physically line them up in order and pick that middle value, the median is 16. But if we want to sort of balance them all out, the arithmetic mean comes out to 18. See how each one gives us a slightly different center? Today, though, our primary focus is going all in on mastering that mean.
Moving right along to Section 2, Calculating the basic mean.
Let's see how this builds into our very first formula of the day. Now, as this writes out, really try to commit it to memory. The arithmetic mean equals the sum of the values divided by their number. It's actually super intuitive. You're literally just taking everything, adding it up into one big pile, and then sharing it out equally among however many items you have.
Okay, let's apply this to a slightly trickier problem. This is a common exam question, folks, so pay close attention to how we write this out. The question asks, if the median of 6 consecutive even numbers is 39, find the arithmetic mean of the smallest two numbers. All right, first things first, let's uncover those hidden numbers. Since the median is 39 and we have an even number of items, that 39 sits directly between our third and fourth numbers. So let's count backwards and forwards. The three even numbers just below 39 are 38, 36, and 34. And the three just above, 40, 42, and 44. Now the question specifically asks for the mean of the smallest two numbers, which, looking at our list, are clearly 34 and 36. So we set up our equation. 34 plus 36, all divided by 2.
And the math is easy from here. 34 plus 36 equals 70. Divide that by 2 and boom, we get 35. Let's just draw a nice bold circle around that final answer. We just beautifully combined logic with our new mean formula.
All right, Section 3, Tackling frequency tables. Now, what if you're surveying a whole school? You obviously can't just write out 1,000 individual numbers in a single massive line. We need a smart way to handle lots of repeating data without adding forever. Enter the frequency table formula. And hey, don't let those Greek letters scare you. That giant E shape, it's just the sigma symbol, and literally all it means is the sum of. So you just multiply each value by how often it appears, add those all up, and divide by the total number of items.
This brilliantly illustrates exactly how it works in practice. So here we're looking at the masses of 30 students. Look at that first row. The mass, or X, is 35 kilograms, and the frequency, F, is 4 students. Why in the world do we multiply them? Because 4 students weigh 35 kilograms each. Multiplying 35 by 4 to get 140 is just so much faster than writing 35 plus 35 plus 35 plus 35, right? As those products fill into that third column, 380, 336, 216, 104, you can see we are just finding the total mass for each specific group. Finally, we sum the frequencies to get our 30 total students, and we sum our products to get a massive total combined mass of 1,224 kilograms. To find our final mean, we just take that huge total of 1224, divide it by the 30 students, and we get exactly 40.8 kilograms. Honestly, great job sticking with me there. That is usually the absolute hardest calculation students face in this topic, and you just nailed it.
Moving to Section 4, Spotting Misleading Data.
Now, before we jump into our practice, be careful here. Many students make a huge mistake in this step by trusting the mean too much without looking at the whole picture. Using the arithmetic mean can actually be misleading sometimes. If your data has a normal, even spread, the mean is a highly accurate representation of the center. But if you have extreme outliers, like a few incredibly large or incredibly small numbers, they pull that mean way out of proportion. It's kind of like having 10 people in a room making totally normal salaries and then a billionaire walks in. Suddenly, the mathematical average makes everyone in that room look rich. In cases like that, you're much safer relying on the median or mode.
Okay, Section 5, Guided Practice Problems.
All right, it's time to put pen to paper and lock in these frequency table skills. Here's the setup. We need to find the average daily pocket money over a 2-week period. We have the values, $20, $30, $35, $40, and $50 right alongside their frequencies. I want you to pause the explainer right here, try to find the total sum yourself by drawing out the frequency table and multiplying across before we reveal the solution. Seriously, go ahead, grab your notebook, and give it a try.
Welcome back. Okay, let's write out the steps together and see how you did. You should have added a third column for f times x. Let's check the math. 20 times 2 is 40. 30 times 6 is 180. 35 times 4 is 140. 40 times 1 is 40. And 50 times 1 is 50. Summing those frequencies gives us 14 days, which totally makes sense for a 2-week period. And summing our f times x column gives a grand total of 450. To find the mean, we just divide 450 by 14. If your scratch paper looks anything like this, you absolutely nailed it.
And finally, Section 6, Your Turn, the challenge.
Okay, we've covered the concepts, we've learned the formulas. Now, it's time to level up. Here is your final challenge, based directly on the homework from our source material. David took 5 tests, out of 100 marks each. His first 3 scores are 92, 85, and 78. His ultimate goal is an 80-mark mean across all 5 tests. So here is the challenge. What is the absolute least mark he could get in one of the remaining tests and still hit his goal? Let's see a quick trick to get you started on this. Set up an algebra equation. You already know the final mean, and you know the total number of tests. So, use the basic formula we learned today, but you're going to have to work it backward to find out the total points David needs. Once you have that magic number, subtract the points he already has. Now think about the maximum possible score he could get on test 4 to force test 5 to be as low as mathematically possible. Grab some paper, write out the steps, and see if you can crack this one. Thanks for learning with me today on this explainer. Keep practicing, and I will catch you next time.